everyone. We want to talk about the basics of probability. In order to calculate the probability of something happening, we need to define a few terms at first. So we'll start with the experiment. That's the thing we're actually going to measure from. So it might be something as simple as roll the dice and add the total. It might be pick a card or multiple cards from a well-shuffled deck of cards. It could be flip a coin or flip a coin several times and count the number of tails that occur. In each of these cases, we call this type of probability a priori, or probability where we have prior knowledge, where we already know the likelihood of an outcome. For example, if I flip a coin, I know it's equally likely to land heads or tails. The sample space is the list of all possible outcomes of the experiment. The event is the outcomes that we're actually considering that we want to count. Now, to do the calculations, we'd first calculate the number of outcomes in the sample space. This might be finite, or this might be infinite. If it's finite, we call the number n of s. Now, the number of outcomes in the particular event we're interested in we'll call n of e, and now we can formally define what probability is. Probability is always measured as the probability of a specific event occurring, which in this case would be the number of ways that I can have the event divided by the total number of outcomes possible. So looking at that ratio, you'll notice something. If the event is the sample space, that means it's absolutely certain to occur, then it means the probability of our event will be 1. 1 would be the upper limit of a probability. Yet, if I have an event that is absolutely impossible to occur, that has no outcomes, we would get a probability of 0. So this means that the probability of any particular event must always be a number between 0 and 1. Now let's look at a very specific example. Let's consider the experiment where we flip a fair coin 3 times, and we want to find the probability of getting exactly 2 tails. Now we operate under the assumption that heads and tails are equally likely. So if we flip the coin 3 times, we want to look at all the possible outcomes of this experiment. So the sample space would be heads, 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 tails. Heads, tails, heads, heads, tails, tails. Tails, heads, heads, tails, heads, tails, 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 heads, and tails, tails, tails. So as we can see, there are exactly 8 outcomes. The fact that that's 2 to the 3rd power is no coincidence, but we'll talk about that on another day. So these are all the possible outcomes. All of them are equally likely. The event that we're interested in is the event where we get exactly 2 tails. So let's consider which ones those are. So it looks like that outcome, that outcome, that outcome. So this particular will be heads, tails, 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 heads, tails, 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 heads. So now we can easily see that the number in E is 3, the number in S is 8, so the probability of my particular event occurring, the probability of getting exactly 2 tails on 3 coin flips would be simply 3 over 8.